Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and since last two lectures we are discussing on low stand system strat, and in this lecture also we will continue that discussion. So, we will try to look into the other aspects of low stand system strat. So far we have discussed about the basic characteristics of low stand system strat LST, and we have tried to understand that what are the manifestations in terms of depositional processes, conditions and the depositional products in different parts of the basin, starting from the fluvial to marginal marine to shallow marine and into the deep marine part. So, what we can understand from our previous lecture, that as the low stand shoreline is gradually shifting towards the sea, because there is a regressive condition, and that regressive condition is because of more supply of sediments along with the base level rise. So, when this shoreline is gradually shifting towards the seaward direction, as the low stand condition is gradually progressing forward with time. So, what we can observe is the supply of the coarser sediments is gradually decreasing, and along with that the overall supply of sediments into the system is also gradually decreasing. So, what will happen in those kind of cases? The accumulation of the sediments along the shoreline or beyond the shoreline will be going on at relatively slower rate, though it is still overcoming the rate of rise of the base level, but the rate of progression will be little bit slower if I compare that with respect to the earlier part of the LST. So, that deceleration of the shoreline progression during the late phase of the LST will continue till the end of the LST, when it will become 0, and from there there will be a turnaround with respect to a regressive shoreline changing over into a transgressive shoreline. So, at that point the base level rise, its rate of base level rise will be overpacing the rate of sedimentation. So, what we can expect in LST when we are discussing about the LST, in the upper part of the LST we expect that there will be more accommodation is created. If I compare with respect to the lower part of the LST, in that part the accommodation creation is going on, but the rate of accommodation creation is at a slower rate. But if I compare it with the upper part of the LST, there the rate of accommodation creation is going on at much higher rate. So, we require more sediments to come into the system, and if not more sediments are coming in, then what we will get, gradually more accommodation will be created over there. So, as a result of this imbalance, increasingly more sediment is required to fill the newly created accommodation. So, that accommodation is constantly being created at the shoreline due to this rising base level, and that rate of base level change is gradually increasing. So, during these low stand normal regressive delta lobes which are prograding, particularly when we are looking into the late phase of the LST, they at least try to become more thicker with time, and they try to become more thicker in the offshore direction as the delta lobe is prograding towards the sea. So, we can try to understand this with a simple diagram. Say for example, if this is the self edge area, and in this self edge area, say initially the base level was here, and then the base level is rising up. Say for example, it is going up over here. So, at the initial phase, as already we have discussed, the delta plane will be forming like this, and the delta front or the delta lobe will be forming like this, clinoforms will be forming like this. So, at this time the river gradient was very high. So, coarser sediments were transported in this direction, and they will be also distributed along the delta lobe or delta front. In the next phase, we will get a progradation which will be going on like this. In the next phase, it will be like this, and it will gradually going on like this. So, as we are going up in this direction, when we are reaching somewhere here near to this position, the rate of rise is now going on at very high rate, and maybe it is very close to the rate of sedimentation, though the rate of sedimentation is still going on at high rate, but the rate of base level change is also very high. So, in this kind of condition, the accommodation available now is much higher if I compare this with respect to this initial portion, because at that time the rate of base level change was slower. So, the amount of net accommodation created was low if I compare that with respect to this upper part where the accommodation is created at higher amount. So, definitely those sediments which will try to come over here will try to get accumulated entirely in this part and will make thicker clinoforms, which will try to aggrade, as well as it will try to prograde in the offshore direction, making more thicker units. So, if I look at that overall delta form, it will gradually become more thicker if we move towards the offshore direction as it progrades towards the offshore direction. So, from the lower part of LST to the upper part of LST, within one LST, what we can expect? Gradual change in the thickness of the delta lobes. So, delta lobes will be much more thicker, they will show more aggradational pattern as we move towards the upper part of the LST with respect to the lower part of the LST. So, along with this change in the thickness and the gradual change in the stacking pattern of the delta lobes. Now, what kind of change in stacking pattern? In the early phase of LST, it is only progradation, not much of aggradation, because the accommodation was not sufficient enough for aggradation. We can see some aggradation only in the fluvial part, but not much in the deltaic part, particularly if I talk about the delta lobes. But as we are going up into the LST succession, as we are going up during the LST phase and more accommodation is created, stacking pattern is now aggradational with progradational. So, when this kind of changeover is going on in terms of sediment accumulation pattern and the net accommodation available, we can expect that definitely there is a change in the energy condition of the depositional systems, and those energy changes will lead to a gradual change in the average grain size distribution across the entire delta lobe. So, what kind of change we can expect? The average grain size of successive delta lobes, as we are gradually prograding offshoreward, the average grain size will decrease in response to gradual lowering of the fluvial energy with time. This particular trend is very much similar as we have discussed in case of high stand delta. I will ask you to go back to our previous lecture on high stand delta, where we discussed about how grain size distribution changes when a high stand delta forms initially through aggradation followed by progradation. And it is exactly opposite to the forced regressive delta which is forming near the self edge, where we do not get any kind of aggradational pattern, only progradation goes on and we get more increasing grain size as it continues or as it progrades. So, in this kind of delta, when we are talking about the LST delta lobes, they will show a gradual decrease in the average grain size distribution within the delta lobes as it is gradually prograding during the LST phase. So, what kind of changeover we can expect? So, within say initial phase, if this is the first phase of delta lobe progradation, or rather the first phase of delta lobe formation, if this is the substrate available. So, on this substrate, the initial grains which are available will be through the river which is coming in over here, having a high gradient. So, this river is a braided river, as we have discussed in our previous lecture, and it will supply large amount of sediment and dominantly the coarser grain sediments. Now, as the base level is rising up over here at this level, the river profile is also changing up. So, the energy is decreasing. So, accordingly the distribution of grains or the grains which are carried by the river, they will be supplied over here like this. So, in this grain size range, the coarser grains will be confined over here and more finer grains will be confined in this portion. When the base level will be rising over here, again the fluvial profile is further getting gentler in terms of its gradient, and energy condition is decreasing. So, it will form the next clinoform, which will be like this. So, the shoreline is gradually moving in this direction, and again we will get the coarser grains in this portion, relatively finer grains in that flow, in that particular load in this direction. So, when we talk about the distribution pattern of grain size within the delta lobes, we get more finer distribution pattern as we look at the individual delta lobes. So, the average grain size over here in this particular lobe will be overall very coarser. Finer grains will be in general absent. If I look at over here in the second part, there the average grain size will be bit smaller with respect to the first one, because now the coarser materials are relatively less in terms of their abundance. Similarly, if I look at the third one, in terms of average grain size, it will be again further smaller grain sizes will be more abundant in this particular delta lobe. But along with that, when these delta lobes are gradually being accumulating one after another, they are getting stacked one after another, and at the same time they are prograding. So, what kind of trend we can expect? Within one delta lobe, if I try to understand what is the distribution pattern within the delta lobes. So, in this area we will get the coarsest grain sizes, and as we will move forward, we will get relatively finer grain sizes within that particular delta lobe. Now, when I am looking into the upper one, it is carried further away. So, definitely the coarsest grains are available over here in this portion, and the coarsest materials are available over here, and then the finer materials are distributed in this portion. So, if I draw the first one, so it will be something like this. So, in this one, what was the distribution pattern? The coarser grains were mostly confined over here, and finer grains are distributed in this area. In the first one, the coarser grains were distributed like this, and the finer grains like this. So, if I look at the distribution of average grain size, it is decreasing gradually within the entire delta lobes in successive successions. So, this is the early LST phase, and this is the late LST phase. So, gradually it is changing up. So, within individual delta lobes, as I am moving from onshore to offshore direction, the average grain size distribution is gradually decreasing. But if I make a log anywhere, say for example over here, what kind of distribution I am getting? Mostly the finer grains at the bottom, relatively coarser grains above that, further coarser grains above that, and further coarser grains above that. So, it is going to be always a coarsening upward trend. A coarsening upward trend, if I try to look at the succession, if I try to look at the grain size distribution at any single section. So, within this delta lobe part, during the LST, starting from early LST to late LST phase, we can expect overall vertical coarsening upward trend. But if I look at the overall distribution pattern with respect to onshore to offshore ward distribution of grain sizes, the average grain size will be gradually decreasing towards the late LST. So, this is a very typical, very characteristic property of the delta lobes, which we can observe during the LST phase. This is very much similar with respect to the HST phase as well. We get similar kind of trend during the HST phase, but this is completely different if I compare this one with the delta lobes forming during the falling stage systems tract at the self edge delta, because there we know the more coarser sediments will be distributed as the delta lobe progresses forward. So, if I look at the overall grain size distribution trend along the vertical profile of the LST, what kind of distribution pattern we can observe? If I start with the fluvial system, so in the fluvial part already we have discussed about the depositional processes, mechanisms, and the overall response with respect to the product that we get in the fluvial system. So, definitely in the fluvial system, in the initial part, what we get dominantly the channel fills, and these channel fills are nothing but the filling up of the incised river valley channels. So, those incised valley channels will be filled up by very coarse grain sediments. they will be amalgamating very frequently. So, multiple such coarse grain sediments will be filling up these river channels. So, amalgamated channel fills with very coarse grain size, and they will be associated with some finer grains overbank deposits, which will be very scanty, very rare. As we go up towards the late phase of the LST, there we get again amalgamated channels, but definitely the grain size distribution will be less as the gradient of the river profile is decreasing. Initially the gradient was something like this, and it is decreasing, leading to decrease in energy of the river system, and that will lead to deposition of more finer grain sediments within the amalgamated channel fills, which will be separated by relatively thicker overbank deposits. So, in the fluvial system, what we are getting from early LST to late LST, there will be overall a fining upward trend. Overall, a fining upward trend is observed from early LST to late LST in the fluvial part in terms of average grain size distribution, in terms of overall grain size distribution. So, if I look at in terms of sand is to mud ratio, so gradually the ratio will be very higher at the bottom part, and it will gradually decrease as we move upward, because the proportion of mud will be relatively more with respect to the bottom part. Now, if I look into the central part, that is where the low stand delta is forming. So, in that area already in the previous slide we have discussed. So, there we can see that overall it will be a coarsening upward pattern. If I look at any single section, always it will show a coarsening upward pattern with respect to the grain size distribution within the delta lobe. But if I look at onshore to offshoreward direction, there will be a gradual decrease in average grain size distribution. So, in horizontal direction there will be decrease in average grain size, in the vertical direction always it will be a coarsening up succession in the deltaic part. And if I look into the deep marine part, in the deep marine part, what kind of conditions we can observe over here in the LST? In the previous phase, when this falling stage was going on, at that phase the last deposit was a high density turbidite. Now, on that high density turbidite, during the LST phase we have seen that low density turbidites will be deposited. So, definitely if I look at the overall grain size distribution, the supply of sediments are gradually decreasing, because the fluvial system is gradually onlapping, it is going back, and so the supply of fluvial system, supply of sediments by the fluvial system is also decreasing. It is getting captured into the marginal marine part, and as a result of that, the supply of the coarser clastics into the deep marine part through this turbidity current is also decreasing. So, overall in this portion, what kind of depositional pattern we can expect? Gradually we will get individual units are sand dominated low density turbidites. So, the first turbidite deposit, the low density turbidite, will have relatively higher proportion of sand, and definitely the grain size of those sand will be bit coarser. When the next phase of turbidity current is getting deposited during the LST, definitely there the supply of coarser clastics is further less. So, we can expect the next turbidite deposit having relatively finer, with respect to this first one, relatively finer grains to be deposited here. When the next turbidite will be deposited, we will have further finer sand deposited over here. So, what we are expecting over here, a gradual decrease in the grain size within the low density turbidites as the LST is gradually progressing. So, maybe the first turbidite deposit was deposited like this, the second one will be deposited on this like this, the third one may be like this. Now, within these individual turbidites, as the channels are coming down, as the levit channels are forming over there, and finally they are getting splayed into the basin floor. So, there we can expect this kind of distribution as successive stacking of the turbidity currents, these turbidite deposits will go on during the LST phase. So, in the deep marine part, again we can expect a gradual decrease in grain size as we move from early LST to the late LST. And if I continue that from the FSST phase, then definitely from the late FSST we get a very coarse grain high density turbidites which will be changing into low density turbidites. So, overall it is a fining upward trend. So, within the LST phase, during the entire vertical profile of LST, if I look at any section starting from fluvial to marginal marine to the deep marine part, we can get varied distribution of grain sizes in different parts, and that will result in different types of stratal stacking pattern, that will result in different type of facies architecture characteristic of the LST in these different sedimentary environments. So, with this background, now we can try to understand what are the possibilities in terms of preservation of petroleum as the resource material in this kind of LST deposits. So, if I try to understand what are the possibilities of petroleum plays, so when this base level is rising during the LST, the overall sediment budget indicate that the major concentration of the coarsest grain size is concentrated in the riverborne sediment within the channel fill sediments in the fluvial part, as well as to some extent in the coastal area where delta plains are forming. So, there only the coarsest fractions are getting deposited, are getting concentrated, and definitely we can expect those areas, those sand bodies will act as the best reservoirs, because there the sand mud ratio is highest. So, when this petroleum play, that particular factor comes into consideration, we should always try to look into this kind of coarse grain sands which will be dominantly available in the channel fill areas within the fluvial and coastal delta plain areas. So, from the shell phase, as the system is gradually onlapping, particularly the fluvial system is gradually onlapping. So, if we move towards the landward side, within the fluvial system, we can expect the reservoirs commonly represented in terms of those amalgamated channel fills. So, those amalgamated channel fills under these low accommodation conditions, they will be concentrating high amount of sand, particularly coarse grain sand, which can act as very good reservoir. So, the best fluvial reservoirs of the entire base level cycle during the LST with highest sand mud ratio can be expected within these amalgamated channel fill deposits formed during the early phase of the LST. If I look into the shell phase delta area, and if I look into the open shoreline beach and the shore face area, so in that area also we can expect supply of sand, and they will try to prograde forward, and also during the late phase they will try to aggrade. But this progradation and aggradation will be associated with some amount of supply of mud as well as the overbank deposits. But till the channel fill systems, particularly in the delta plain area, the channel fill systems showing this kind of amalgamation pattern, they can be considered as good reservoirs. And as those sediments will be reworked by the longshore currents, wave activities, and they will be distributed along the shore, forming bars along the shore. So, there we can expect their lateral continuity also, which can be considered as a very good factor, a supportive factor for a good reservoir. So, when we get this kind of channel fill sands coming into the delta plain area in the coastal area, and they are getting laterally distributed by open marine processes, they can also be considered as good reservoirs. So, in terms of petroleum plays, if I now try to look into in terms of different depositional areas, we are discussing in terms of 4 depositional areas. One is the fluvial, one is the coastal or marginal marine, third one is the shallow marine or shelf, and the fourth one is the deep water part. So, in terms of sediment budget, in the fluvial part, it is really very good because it is getting the maximum amount of sediment supply. So, there we get amalgamated channel fills. So, definitely in terms of reservoir condition, those channel fill sediments being the coarsest fraction having the maximum sand mud ratio are the best reservoirs within the LST phase. But the problem is we do not have or we do not get a proper sill rock or cap rock. Also we can lack in terms of the source rock because the supply of finer grain materials, their preservations are significantly less over here. So, in terms of source and sill rock, the conditions are relatively poor. So, if you get supply from other source rocks which may be formed in earlier phase and on that now a fluvial low stand deposit is forming, it can act as a good reservoir. When you look into the deltaic system in the marginal marine area, which may be delta system, which may be also the shore system. So, there we can expect that the supply of sediment is again very good, supply of sand is very good. The sand mud ratio is still significantly high, though it is low with respect to the fluvial part, but still it is significantly high to make it a good reservoir. So, particularly if I talk about the shoreline sand, where we get a continuity, lateral continuity, strikewise continuity, so that can act as a very good reservoir rock. But the problem again here is the same in terms of source and sill rock, because the finer grains are not that continuous, are not that sufficient to provide a proper source and sill rock over here. When you look into the further deeper part into the self area, so commonly we get gradationally based shore face and self deposits, which are actually formed by the reworking of the sediments trapped in the deltaic area. But already in the previous lecture we have discussed that when this kind of LST delta are forming and it is starting from the self edge and gradually the fluvial system is going back and the delta system is progressing. So, the extent of the self deposits, the extent of the self area will be very limited in this kind of condition. So, definitely the overall sediment budget will be relatively poor if I compare that with respect to the fluvial and coastal system. In terms of the reservoir quality, when the shore face sands will prograde up to this area, that can act as a good reservoir. And here we can get a cap rock or maybe a source rock, which can be the fine grain sediments which are available in the self area that can act as a source rock or a cap rock. Now, looking into the deep water part, here we are getting low density turbidity currents. So, definitely the grain size is relatively less, as well as we are getting some mud supply, particularly when there is a gap in between two successive turbidity currents, then the basinal condition will prevail and mud will get deposited, mostly pelagic and hemipelagic mud will get deposited. So, that can disturb or that can reduce the quality of the reservoir. So, here in this condition we can get the turbidite deposits, the low density turbidite as a reservoir, provided the supply of mud is less. On the other hand, supply of this mud can act as a good source rock, they can act as a good cap rock as well. So, overall in terms of petroleum play condition in the deep marine part, it is a mixed kind of condition. It is not very good, not very bad. Depending on condition, it may vary from basin to basin, depending on what is the supply of sand and what is the rate of deposition of mud, basinal mud in that particular area. So, overall in terms of petroleum play, the LST successions are quite varied in terms of their occurrences, in terms of their origin, in terms of their processes, because always the sand mud ratio, it is significantly varying from area to area. And also during our previous discussions during this lecture and also in the previous lecture, we have seen that the proportion of grain size distribution is varying from early LST to late LST. The distribution of the grain size in different areas are also varying from early LST to late LST. So, we can expect good reservoirs to form in fluvial condition, in the deltaic part, in the marginal marine part in the form of strand plains or in the deep marine system as well. But certain conditions has to be fulfilled. and then only we can expect good petroleum play to form in the LST succession. If we look into the in terms of coal resources, it is not very favorable for coal forming condition for coal resources, because the conditions required for coal accumulation, peat accumulation are not available during the LST. Because overall, as we have seen through our discussion on LST, it is overall a very high energy condition where the clastic supply, coarse grain supply is very high. And when we have in the depositional environment lot of sediment supply in terms of coarser clastics, so there we cannot expect good quality coal to form. There we cannot expect peat forming mire condition to develop. So chances of peat accumulation and subsequent coal development tend to improve toward the top part of the LST, where the accumulation is increasing, the net accumulation creation is going on at faster rate, and that is leading to more frequent and thicker overbank deposits. So in those conditions, in those overbank areas, we can expect formation of some coal forming condition, some peat forming mires to form over there in those kind of overbank areas during the late phase of LST. Otherwise, in the LST phase, we do not expect good coal resources. If I talk about the placer deposits, again during the LST phase, we do not expect placer deposits to form because no erosions are going on, or prominent erosions are not going on at all during the LST phase. Rather, it is a more depositional phase. But importantly, as we have seen during our discussion on the FSST, we have seen that major placer deposits form or they remain associated with the unconformity surfaces, or they get associated with the shoreline erosional processes, which is RSME surfaces. And importantly, the LST deposits, they start growing, they start depositing on these erosional surfaces, the unconformity surface or these RSME surfaces. So many times the LST deposit starts with these placer deposits, or at the bottom part of the LST deposits we get these placer deposits which have actually formed during the late phase of forced regression, but they finally occur within the LST deposits. So often we also can expect this kind of placer deposits to form associated with the TRS, transgressive raffinement surface, during the transgressive phase, when commonly we get the truncation of the top of the low stand deposits, and there we can get local concentrations of placer deposits. So with this we will conclude our discussion on the low stand systems tract. So overall we have discussed about all the aspects of low stand systems tract in terms of change in the depositional conditions with respect to base level change and sediment supply. We have tried to discuss about how the change in base level position will affect the river profile, the river gradient, and how that is controlling the distribution of grain size, the distribution of dominant depositional systems in different parts of the basin, and what are the resultant products in terms of vertical succession, in terms of stratal stacking pattern, and how they are changing with time from early phase of LST to late phase of LST. We have also tried to understand that how these overall changeover in terms of depositional system and grain size distribution are affecting the accumulation of different resources, natural resources like petroleum, like coal or placer deposits. So these are some references that you can go through for further reading. So thank you everybody.